This is question 29 from section B of the 2018 PBSAA paper. In this question, we're given three lines in a variety of different forms. X equals 0, 5x plus 2y is equal to 20, and y equals 3x minus 23. And we're told that these three lines enclose some region, let's call it A, and we're asked what's the area of A. So we need to find the area of A, which is formed by all of this. But I don't know about you, but I really don't know what this looks like. So what do you think we do? I'd go for a diagram. So sketch the x and y axes here and try and put our lines on, see what we get, and we can work from there. So we'll start with this one, because this one's really nice. X equals 0. Well, that's here, so it's just a y-axis. So we can plot that in red here. And now we'll go for this one, 5x plus 2y equals 20. Now your first instinct may be to rearrange this, but I don't think it'll particularly help, because all we want is a rough sketch, right, to see what's going on. So if we work out 2 points on this line, say here and here roughly, we know what to draw. So let's shove in x equals 0 to see where it intersects the y-axis. So if x equals 0, we want to solve this essentially, which this is just 0, so you can certainly get rid of that, and we get y equals 10. And so we can plot that on our graph. Similarly, we can shove in y equals 0. So if we do that, we want to solve this. 5x plus 2 lots of 0 equals 20. 5x is 20, and x equals 4. And so we can put 4 on the graph here. And we can put in our line as such. And we do exactly the same for our final equation here. So let's shove in x equals 0. And y equals 3 lots of 0 minus 23. So y equals minus 23. So there you can see this straight from here because it's the form y equals mx plus c. But anyway, this is our intersection with the y-axis. And so minus 23 is a point here. And we can work similarly for y equals 0. So we sub y equals 0 here. We get 0 equals 3x minus 23. So 3x is equal to 23. So x equals 23 over 3. Not particularly obvious where that goes in the graph, but you can rewrite it as 7 2/3. And so it's fairly obvious now it goes roughly here. And we can draw the line in as such. So we have our graph all built up here, and the shaded area gives the area of A, because it's the area enclosed by these three lines. So we won't work out the area of this. So that's a half base times height. So we'll take this as the base, because this is a length we just full on know. And we know it to be 33, because it's minus 23 and 10 up here. Now the other thing we want is this, the height. But the thing is, we don't know this coordinate. What we need is the x coordinate of this point. And then we have the base and the height, and we can work out the area. So how do we do that? Well, we know it's the intersection of the green and blue lines, the intersection of these two. And we want to find the x coordinate, so preferably we want an equation x. So if we take this expression for y and shove it in here and do a bit of rearrangement, we should find x. So indeed, that's what we do. Shove y equals 3x minus 23 into here, and we get here. Collecting the terms by expanding this bracket out, 11x minus 46 is 20. So we get 11x 66, x equals 6. So we've got x equals 6, so we know that the x coordinate of this point is 6. So we've got the base and the height. So we're nearly there. So we need a half base times height for this triangle, which is area half times 33 times 6. 6 over 2 is 3, so we'll just 33 times 3. And that's a calculation that's fairly easy to do in your head. That's 99, which is great news, because that's one of the multiple choice answers. It's actually C. So our answer is C.